my wings. All right, math magic is what we're going to learn today. And it's a process that makes division much easier, but it only works when x minus a is what we have, and it's a linear factor. So what we do is, instead of all the stuff we did yesterday, we're going to add and we're going to multiply. That's all we're going to do today, add and multiply. And we're going to be able to get the answers that we had for some of these yesterday. So use synthetic division to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. What's the quotient and the remainder? Yesterday we would have done this by long division. We don't need to do that anymore. They just told us use a in this linear factor. So using a means using the 0. And we know the 0 for that would be negative 2. But now this doesn't look the same way as normal long division does. Here's why. Synthetic means man-made. Somebody noticed this pattern and they said, hey, this is really cool. I wonder if this will work all the time. And then they proved it using algebra, and we know that it works. So what we do is kind of a little upside down division. You know, that negative 2, the divisor out in front actually gets that upside down division symbol. And then we draw a line here so that when we're doing our calculations, we have a spot to go to. And now here's the cool thing about synthetic division. What holds us back when we're working with this is all of the x's that are involved. And it actually, when you have a linear factor, works without the x's. So what you do is you look at it at your, what would normally be your dividend. What are you dividing by here? And you make sure that everything's there. If something's missing, we have to put a 0 in for it. So third power, the next one better be a 2, or we're going to need a 0. 2, 1, 0. All of them are there. But we don't use the x's, we just take the coefficients, the numbers in front. So this is a 1x cubed, a negative 14x squared, a 51x, and minus 54. Things to remember, write this down on the outside. Inside the box, add. If you're inside the box, you're going to add. Outside the box, multiply by a. So inside the box we add. Outside the box we multiply by a. Magic. It's called a leading coefficient for a reason. It's where we start. It leads the process. So we're going to bring this 1 down, and we'll always do that with the leading coefficient. The leading coefficient starts the process. But now I'm outside the box. And this process always goes outside the box, inside the box, outside the box, inside the box. Alternates from those two. So if I'm outside the box, I'm supposed to multiply by a. 1 times negative 2 is negative 2. But now I have to go back in the box. So I'm in the box. When I'm in the box, I'm supposed to add. And I go outside the box. Now I'm outside the box, and I multiply by a. Now I'm inside the box, so I need to add. Outside the box, multiply. Bless you. Inside the box, what do? Add. Ta-da! Math magic! Well, that's our answer. We just have to put it back together. And you always start over here, and this is your remainder. Every time, that last number over there is your remainder. The next one is your constant. The next one is your x term. The next one is your x to the second term. The next one would be x to the third, x to the fourth, x to the fifth, x to the sixth, etc. So our answer is x squared minus 16x plus 83 minus 220 over x plus 2. Ta-da! Now do you see why it's such a big deal? Do you remember long division yesterday? Yeah, we didn't have to do that, did we? Look at this. Love it! Inside the box add, outside the box multiply. Now why does it work? Because I'm a big Y person. The proof that you use for this is called nested factoring. And so it's a little bit different than what we've seen before, and I might just show it to you, but know that later on when you get into the higher levels of math, the proof of this would make total sense. You know, it's one of those things. Because what we have to do is we have to factor from the left-hand side, which is something we're not used to doing. And then we know this process works. Beautiful. No long division. Excellent. The problem, can't use it for everything. Has to be x minus a. Has to be. So there were some yesterday, there's no way around it. We would have had to use long division. But there would be some now that if we went back, we said, hey, wait a minute. I can do that the short way. Math magic. Alrighty, this one, we're going to use synthetic division to divide x cubed minus 57x plus 56. And I stop right there and I think, oh, something's missing. I can't do my magic if that x squared's not there. I'm going to have to put a 0 in that spot. But it is linear, x minus 7. So the 7, remember, it's just like thinking I need the 0. You know, that's what we're going to do our division with. So I start thinking, I've got a 1x cubed, a 0x squared, a negative 57x, and then 56 for the constant. So the only one that was missing was the x squared, but I have to have that 0 in there. Synthetic doesn't work if that 0 is there. Even if your constant is missing, let's just say this had stopped right here at negative 57x. We'd have to put a 0 on there to make sure that that's going to work. All right, line for calculations. How do we start? Bring the 1 down, leading coefficient. Called that for a reason. You're outside the box. What do you do? Then you're inside the box. When you're inside the box, you add. Outside the box. Inside the box. Add. Negative. Outside the box. Here's why I wondered. Look what's going to happen. Aha! It's a factor. There's no remainder. This one is perfect. We're not done yet because we need to write our answer, but ta-da! See, it's magic. Didn't have to do all the long division. No remainder. Constant x squared. This is x squared plus 7x minus 8. There's our answer. There's our answer. Boy, I wish we could have done that for everything yesterday. Oh, you can't. Has to be that x minus a. Love it. It's magic. It's magic. It even helps us with word problems. Magic. Using synthetic division to solve a problem. The polynomial x cubed plus 7x squared minus 38x minus 240. Stop and think. What are you checking for while you go through that? Are they all there? Are they? 3, 2, 1, 0. They're all there. That expresses the volume in cubic inches of this lovely little shadow box with seashells down here. Fairies like the beach. It's a good place. Fly over that. What are the dimensions of the box? Uh-oh. What are the dimensions of the box? How are we supposed to know? The length is greater than the height or the depth. Okay. Oh, wait a minute. There's a hint. There's a little x plus 5 down here. Can you see that on yours, or is it too dark? A little x plus 5 down there. Well, hey, if we know that one, can't we work our way down to a quadratic? And maybe we can factor it. Magic. So what do we use in the little box? Negative 5. Everything was there. You told me that. I'm going to go for it. So 1, 7, negative 38, negative 240. Now, I'm going to think ahead a little bit. They're telling me that x plus 5 has to work by showing me that picture. So what's going to happen at this last step? Should it be a 0 for a remainder? If it isn't, we messed up somewhere. How do we start? Bring her down, leading coefficient. Outside the box, what do? Multiply. Inside the box, add. Outside the box, inside the box. What do you suppose negative 48 times negative 5 is? Now we have to think about what we have left because they asked us for the other ones. So, remainder, constant, x squared. We have x squared plus 2x minus 48 equals, I think we can factor that. Let's see here. It's not greatest common factor. It's not perfect square trinomial, but I'm pretty sure we know two numbers that multiply to negative 48 and add to 2. 8 and negative 6. Well, those are the other dimensions. Now, they did want us to label them, so they told us one is bigger than the other. So let's go back up here. It said the length is bigger than the height. Okay, so of these two factors here, oh, and actually we wouldn't need the zeros because they're not going to give us numbers right now. They're going to do that in the next one. But which one of those, think about putting an x in there, which one will always give you the bigger number? The x plus 8. You put a number in here and you add 8 to it, that's going to be bigger than subtracting 6 from something. So the length has to be the x plus 8. And then they said we could call the other one depth if we want to, but height would be x minus 6. And just so that we have all of our bases covered here, we probably better put our little x plus 5 down here too. So if we have length and height, then this is width. Get any numbers to do anything with? Nothing. That's it. So we could just label all of these inches, but until somebody tells us a number, there's not a whole lot we can do. We can't give them the dimensions. Which brings us to this, where it says if the width of the box is 15 inches, what are the other two dimensions? All right then, let's see. That was width. So x plus 5, they're telling us is 15. What does that make x? If we know x is 10, can we find the other two? Sure, you have nice little formulas right up here. 10 plus 8. 10 minus 6. We've got it. Magic. Even word problems are easier. Yes. Synthetic. So cool. So cool. This one says, if we change this up now, and the polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of the box, and a width of x plus 1 inches, now what are the dimensions of the box? Go ahead and do this one. Use your magic. When you get done, check in with the chicken wing elbow partner. There's the first spot that somebody could have made a mistake. They could have looked up there and said, oh, it's x plus 1, I'm going to put a plus 1 in here. No, we have to use the opposite. It's always the 0. X to the third, x squared, x to the first. We do have them all. Bring down that leading coefficient. Outside the box, multiply. Inside the box, add. Outside the box, multiply. Inside the box, add. Outside the box, multiply. Inside the box, add. So something went wrong somewhere in there. Check and see, what happened. So no remainder, which we knew was supposed to happen. That's always a good thing to know in advance. X squared plus 5x plus 6. So then you had to find yourself two numbers that multiply to 6 and add to 5, and that's 2 and 3. So there are the other dimensions. We've got the x plus 1 up here that we already started with. And the other two would be x plus 2 and x plus 3, and then we'd want to tack on that all of these were supposed to be in inches. So Little mistakes, like I said, by maybe 3 or 4 people as I walked around. Otherwise, your math magic is going very, very well. It is. So, I mentioned earlier, this isn't just called synthetic division. That would let you know that there's something else that we use this for. And what we can use this for is called synthetic division. What we've called that in the past is evaluate. And evaluating can actually be done synthetically. So you can take the x's out of the picture and figure out what you have. So the remainder theorem provides a quick way to find the remainder of a polynomial long division problem. Again, you have to have that x minus a. So if you divide a polynomial p of x where the degree is greater than or equal to 1, so at least linear, by x minus a, then your remainder is p of a. It is what do you get when you put a in. Now, why on earth would that possibly work? Let's take a peek at what we already know. That if we do the division, we get a quotient and we get a remainder. So, if x minus a is what we're using as one of those factors, we're going to substitute that in. Now, a is then supposed to be a 0. So if we put a in for x, this is going to be 0. And what's going to be left is our remainder. And that's how synthetic substitution works. Now, generally people look at this formula and go, what on earth? So that's why it's supposed to be kind of funny here, because you look at that and you go, good grief, what on earth are they saying here? They're saying we can use this to basically substitute a number in, and our answer will just be the last number. It has to be. Our remainder is the answer. Because of the fact that we are using one of the factors, when we multiply those two pieces together, we're back to 0. So down here, it says, evaluating a polynomial, given that p of x equals, and we see a formula there. Normally we would have said, okay, they want p of 3. I'm going to put a 3 in for all of those. Grab a calculator. 3 to the 5th. No. Do the math in your head. Do it synthetically. Put the 3 out here. We don't have to make that negative because it's not in that x minus a format. You just put the 3 out in front. You notice, hey, I'm missing stuff. So 1x to the 5th, but 0x to the 4th, negative 2x cubed, negative 1x squared, 0x, and a 2. Again, all the way down to the constant. If even the constant is missing, we need a 0. And then we just quickly do this synthetically. I mean, these are nice numbers. They're small. So we bring down the 1, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, and we add. And that last number over there, our remainder, that is absolutely what you would get if you put a 3 into this polynomial. That's our answer, right there. No calculator. No sitting there saying 3 to the 5th. Let's see. 3 times 3 times 3 is 27. 27 times 3 is 81. 81 times 3, that's going to be 243. No. Synthetically. Synthetically. Use the synthetic. Math magic. Not even going to bother showing you the gridded response because the MCAs now don't do gridded response. In the old days, just so you know, they used to have you fill in little blocks and all that stuff on paper. But you guys will take your MCAs on the computer. So here's a beautiful, beautiful problem for you to do math magic. So give it a try. First place an arrow is going to occur, Eric will occur is that 0 over there. Some people may have forgotten the 0. Did you feel like you'd done something wrong when you got a 0 over there? Yeah, that, every once in a while, because it's synthetic. The hard part to know about this is, did I do this right? Because there are so many shortcuts that we're taking here. It wouldn't hurt, to go through the old way and put the -4 in and make sure you do get 0 if this is on the test. But you gotta agree, synthetic is super cool. That is super cool. So our objective today was to use synthetic division and synthetic substitution. 43210 me. How do you feel about the synthetic? In case you can't tell, I kind of love it. All right, fantastic. Good numbers. Have fun. It's playing with math. That's what it is. It's playing. Every once in a while we get to play. Play. Heads up that right before break, which is going to be the 22nd, that's when we're going to be taking our Chapter 5 test. Just to make sure everybody is keeping up on the homework. Hold on. Things are going to go pretty fast here.